Welcome to the 8th Vision Science Research video. In this video, we'll discuss how to appraise and select sources for your topic. First of all, why is it important to appraise the evidence? The process of sharing research methods and results transparently is part of the scientific process. The purpose is not only to share the results, but also to enable others to critique the methods and results and find flaws and errors or to disprove hypotheses. This is essential to the scientific process and allows for errors to be corrected, and you're a part of this process. As someone reading and using this information, it's your responsibility to think critically about it before considering how to use it. So just because it's a research study in a peer-reviewed journal does not make it error-proof. Think of all of these studies as there for you to critique and think critically about so they can be improved upon. With that in mind, we'll start off with 3 questions. Will the research design help me answer my clinical or research question? What are the limitations of the research, and is it from a trusted source of information? We had discussed previously about how some study designs were best suited to answering different types of questions. So you could check to see what type of study you're looking at to see whether it's one of the preferred study types for your type of question. You can check the British Medical Journal's glossary of evidence-based medicine terms for definitions and descriptions of different types of studies. However, in general, you can use this hierarchy of evidence to determine how much weight you should give the results of the study in relation to answering your clinical question. At the bottom, at the least valid, would be background information and expert opinion. These would be our reviews, medical textbooks, and pieces based upon expert opinion. They can give you good background information, but are generally not considered good evidence for clinical decision-making. Next would be unfiltered information through studies such as randomized controlled trials, cohort studies, case-controlled studies, or case series, or case reports. These are all single studies. You can see that randomized controlled trials are higher up because their study design is stronger, but that they're still in the middle of the pyramid. This is because they're single studies. Just because a single study has one result doesn't mean that another study with the same methodology would have the same result. Studies need to be repeated to see what the results are, and after they've been repeated many times, the stronger conclusions can be drawn and based upon their combined results. This is where the filtered information comes in at the top of the pyramid. The filtered information is essentially summaries of many studies on a topic where a body of literature is looked at and conclusions are drawn. Thus, if you find systematic reviews or critically appraised topics, you can know that you're looking at stronger evidence. Meta-analyses are really at the top of the pyramid because they're essentially like systematic reviews that have used statistical analysis of the combined results of the literature on the topic to draw conclusions about it. When done well, the statistical analysis about multiple studies is very strong evidence. The graphic also shows how observational studies are at the lower levels of evidence, where experimental studies are at the higher levels, since they can usually account for more variables when studies of studies. And then studies of studies, systematic reviews, and meta-analyses are at the top. So if you can find studies that are closer to the top of the evidence pyramid, you can feel more confident about their conclusions. The American Optometric Association provides a key to quality of evidence and strength of clinical recommendation grading. This tool assigns grades to evidence based upon their study design. So just like our pyramid, meta-analyses and systematic reviews are at the highest level, grade A. Well-designed randomized controlled trials and diagnostic studies are also grade A. Experimental studies have higher grades, while observational studies have lower grades. The lowest grade is D, and it includes cross-sectional studies, case reports, case series, reviews, position papers, expert opinion, and reasoning from principle. In addition to considering study design, your job as a scientist is to really think critically about the next section. Did the study have a clearly stated and focused aim or objective? How well was the study designed? Did the study clearly describe the methods, including the intervention protocol and the relevant characteristics of the population? Did the investigators use blinding or random assignment? Did the study objectively identify and account for other confounding factors, such as those from the restrictions of the study design? Overall, critique their methods and stay tuned to identify any possible flaws and consider how they could be improved. Another important thing to consider would be conflict of interest and publication bias. While researchers are supposed to declare any conflicts of interest, some ways to identify it may be when a study appears to sensationalize the information, there's a lack of peer review, or the organization has an alternative agenda, which is not purely the advancement of scientific knowledge. Publication bias occurs when the results of a study influence whether or not the study is published. Unfortunately, studies with positive or significant findings are more likely to be published than those with null or negative findings. This means that when you look at the literature on a topic, you might be seeing more positive or significant findings published simply because studies with null or negative findings were not published as frequently. This provides us with a skewed image of the topic. Null and negative findings are very important to understanding it, so be aware that this could be happening when you look at the literature on a topic. Last of all, consider whether the study provides statistical information such as confidence intervals or effect sizes about the outcomes. This will help you determine whether the results are statistically significant and also meaningful. Essentially, you want to know whether the evidence is strong enough to make a clinical decision, and you want to determine whether you can generalize the results to your clients. If you can find synthesized evidence at the higher levels, this can save you time since they should include a bias assessment of the studies that they include. Let's practice determining several articles' relevance to our clinical question and determining their study design and AOA's quality of evidence grade. Of course, you still need to look at the study design itself to see how well designed it was, but this will give you a good starting point. So here's the abstract of our first article. We can see that the abstract has different sections: purpose, design, participants, methods, main outcome measures, results, and conclusions. When we see the methods and results section, we know it has to be a study of some sort. Here's the citation and selected parts from the abstract. It calls itself a randomized placebo-controlled double-masked trial. It looks like it's relevant to our population and treatment because the participants were aged 4 to 12 years old and the treatment is for myopia control. And that was 0.5%, 0.25%, and 0.01%. Excuse me, 0.05, 0.025, and 0.01% atropine eye drops, or a placebo eye drop. The study does appear to be a randomized controlled trial. The results that would be especially relevant to our question are that 0.05% was most effective in spherical elongation progression and axial length elongation over a period of 1 year. So this matches the definition of a randomized controlled trial, and we might assign it either grades A or B evidence based upon the study design when we look further into that to see how strong it is. So here's the next article that we found. Notice that it does not have an abstract showing the typical research study section, such as methods and results section. Instead, it's a paragraph of text with a summary of what the article will discuss. From this alone, we expect that it's a review and it's not a research study. When we look more closely at the abstract, we see that it's definitely a review. It's not a study. It's going to be citing many studies, but this is not a study itself. This would be a great article to read to get an overview of myopia. The review does mention low atropine eye drops, and so we might be able to find references to research art studies if we check the references of this article. This is a review and it's not a research study, and so it would be grade D evidence. So the next one we'll look at states that it's a meta-analysis, and we can see that it has the typical research study sections in the abstract. Looking at selected portions of the abstract, we see that it looks like it's on topic. It's looking at atropine treatment for myopia in children, and they used 8 different atropine concentrations from 1% to 0.01%. It appears to be a meta-analysis because they describe their methods for finding and selecting studies and talk about how they extracted data from the different studies that they included and performed a statistical analysis on their pooled results. So they found that 0.05% atropine was comparable with higher doses of 1% and 5% and 0.5%. So this would be a meta-analysis and it would be grade A. Well, thanks for watching these videos. If you need any general help from the library, here's the contact information, and you can contact me to work with you on your research. I can help you with selecting a research topic, focusing your topic, developing a search strategy, identifying information sources or databases to search, finding references and information for your research question, evaluating and selecting references, and citing your sources. You can reach me by phone, email, or you can schedule a meeting directly to my calendar using the Calendly link provided in this slide. Everyone at the library is here as a team to support you, so please reach out anytime.